So now we're going to talk about the voltage-gated sodium channel kinetics. Now, over here, we're going to call this number 1. This is when the voltage-gated sodium channel is in the deactivated state. It's resting. And we know that at rest, the membrane potential is quite negative. And we can see that there's these gating charges that are part of the voltage-gated sodium channel protein. And the reason why they're closer to the inside of the cell as opposed to the outside, which there are also some negative charges, is that there's more negativity attracting those charges in that direction. And that keeps the channel in the closed state. This little purple protein here is the inactivation gate that is just sitting off to the side. Now, when we have our depolarization, our depolarizing stimulus, we know that that is what is going to open up the voltage-gated sodium channels because they are voltage-gated. This is a voltage-dependent process. What's going to happen is there's going to be less negative charge on the inside, right? There's less negativity because of the depolarizing stimulus. And what that's going to do is if we keep these negative charges over here, these positive charges are going to migrate and move, okay? And as they move, that is going to open up the channel, cause a conformational change, and open up the sodium channel pore. And now that's going to allow sodium to go in to the cell and cause more depolarization. And this second channel state is called the activated state. The sodium channel is activated, conducting sodium through the channel. Now, we still have this inactivation gate off to the side. And what's going to happen is as soon as the channel opens up, that inactivation gate is going to be attracted to that pore. And so very quickly, as we transition from number 2 to number 3, this is going to be transitioning us in a time-dependent manner. And that flap is going to move into the pore. And so we can draw that here, blocking the channel pore. So we still have the channel was opened in response to that conformational change, but now sodium cannot go through. And that is what we would call the inactivated state. So we still have these positive charges that are still in this location, and that was what was opening up the channel, activating it. But this inactivation gate blocks sodium from going through. And in order for us to get back to the deactivated state, we have to have repolarization, restoring the membrane potential and moving those positive charges back. So this is also voltage dependent as well. This requires repolarization. And so that is how the sodium channel functions. And I want to point out that as soon as the sodium channel opens, very quickly the sodium channel inactivates. So it's not a lot of time, and it's a very fast process. And we're going to discuss there's some significance to this in terms of the action potential and also the refractory period.